Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In this video, I'm going to revisit an older video. I get a lot of questions on an old video where I interfaced the Nextion display with a TB6600 stepper motor driver. It runs really slow, and I've changed the way I do things, so I thought an updated video on this would be nice so that I can refer people to it when they ask questions. I'm going to go over the old one first, just if you haven't seen it, you'll see what I'm talking about and how things have changed if you watch my recent videos. In the old display, I simply had a forward and reverse button. You'd press the forward, the motor would spin forward. You release it, it would stop. Same with reverse, it would spin in reverse, then if you released it, it would stop. And then the slider was supposed to represent the speed. So in this case, I have my speed SPD. I add the value that's stored in HO, convert it to text, compile or concatenate it all together, and then send it out the serial port. But you'll notice that I don't have a beginning or an ending delimiter, and now I'm starting to use C:C as my beginning delimiter and then a question mark as my ending. I do the same thing with the buttons. So I do BT1 for forward and BT2 for reverse, and then I send an OF or an ON for on and off. But the rest of this is similar to what I do now. In this case, I'm using a nano, so I have to have the software serial involved. The void setup is pretty much the same. You initialize both the serial ports. In this case, I set my pins, because for the TB6600 you have a clock pin, a direction pin, and an enable pin, and then you always want to initialize it to low, which I believe that's actually enabled as low. So I got that backwards back then. I'm pretty sure high is off and low is enabled. And then when I read my information, I read in that DFD. I read it all in at once. Now I've switched to I read one character at a time and I look for that delimiter as it's coming in. And since I read in the values all at once, I have to reset that DFD every time. Now I have a whole subroutine or a whole if statement that I go through, and then at the end of it I reset the DFD. And then I do logic based on command and value rather than the whole string. Now in my motor delay, for the video itself, if you go back and watch it, and I'll have a link down in the bottom to that video, you'll notice that the motor spins really slow, even though we have the delay set to 1. And that's because we're using milliseconds for our delay. And in the new video, the one I'm going to show you next, we're going to use microseconds. And a microsecond is 1,000th of a second, of a millisecond. So we should be able to get a much faster response, and the motor should spin a lot faster. And now I'm going to move over to the new configuration. And for this new one, I've just gotten a little more polished, I guess, and maybe my setup, because I've started adding the Cheap Controls logo in the last few, and I put a little text on it just to make it look a little nicer. They don't do anything, but they're there. I have the forward and reverse buttons, just like in the last video, and then the slider. I did add this because this is going to provide us a little feedback, and it's a radio button. And it doesn't have any events tied to it. But what we can do is we can change the color. And what I've done is I've set the BCO and PCO to be the same color, and it's 216. And we're going to fluctuate between that green and then this red down here. And so that's going to give us an indication of if the motor is, or if the display is not in direct communication with the Arduino. Because the other thing I've done as time has gone by is I've started to add feedback, so that way the Nextion doesn't just assume that the motor is started or stopped. It actually wants to get something back from the Arduino to say that it's started or stopped. And now when I press the forward button, it's going to send, you can ignore this motor lock up here for right now, but it's going to print C:C, which is my beginning delimiter, run, and then which will be the command, RUN, and then the value is going to be forward. And the reverse is going to do the same command, run, only it's going to go in reverse. So we'll have the same command, but we'll be looking for different values. And then when we release forward and reverse, we're not going to do anything, but we're going to enable a timer, and we're going to set that motor lock to 1. And that's the same for both buttons. And if you look at this motor lock, it's only going to send this command if it's equal to 0. And also notice that I don't have to put the .val on it, and that's because it's part of this program.s. I added motor lock right here, and I initially set it equal to 0. And that means when we start up the display, if we push this forward button, we'll send the command, and we'll assume the motor's going to start. But when we release the button, it's going to go to a locked state. And then we won't be able to push either one of these buttons. We'll be able to push them, but they won't send the command to start the motor. And we'll get into this timer enable here in a minute. But the command down here, or this slider, this operates the same as the slider did in the past one. We're still sending the speed. We're still going to convert up here with the covx. We're going to convert the value of this and store it in a variable called value. And then we're going to build our send string, and we're going to put C:C. We're going to concatenate SPD, and then we're going to add the value, and then we're going to finish it with that question mark, and then we're going to send it out. We're only going to do that on release. In some of my videos I do it on move and I do it on release, but for this one I just have it on the release. This timer is going to send the command mtrof, and it's going to send it every 400 milliseconds because that's the default of the timer, so about every half second. And what it's also going to do is every half second it's going to change this radio button. It's going to change the color of it, and if it's green it's going to turn it red, and if it's anything other than green, which will be red, it'll turn it back to green. So every half second this is going to flash, and it's going to send this command out. So the order is going to be, we'll press forward or reverse. It will push the motor in forward or reverse. Releasing the command or releasing the button isn't going to do anything, but it will start this timer, and then the timer is going to send the command to turn off the motor, and it's going to send that command over and over and over again. And we're going to rely on the Arduino to send a command back to the Nextion to stop that command from being sent, because we want to make sure the motor gets turned off. We're not really too concerned if it doesn't get turned on. If you hit that forward button and it doesn't turn on, you're probably just going to hit the forward button again. But if it doesn't turn off, that's where you can have a problem. You can also notice that in this command, at no point do we turn the motor lock off. Once it is turned on by the forward or reverse buttons, you can't hit these buttons again until that gets set back to 0. So we're going to rely on the Arduino to say, yes, we've stopped the motor. It's okay to turn it on again. Now I'm going to switch over to the Arduino. Now in this video, all we're going to be doing is turning the motors on and off. So I don't have a separate tab up here for the delay. I'm going to incorporate it into the main program, but I will have a tab for the input. I'm going to use a nano just like in the last example in the older video, so I will need this software serial command. I'm going to set my delay length to 1800. I didn't show that over on the Nextion side, but I'm going to have the motor controller, or the HO, the slider, is going to be between 300 and 3300. So we'll have a 3000 range that we can select, and that will, in the middle of that is 1800. So we'll start at 1800 for here, and I have the slider set to 1800 on the Nextion. I'll verify that here. You can see that the value of this is set to 1800, and my minimum is 300, and my maximum is 3300. So that way, as I slide this slider back and forth, it's going to put a speed of 300 to 3300 out. And for the motor itself, we'll have a motor clock pin. We'll have it set to 8. We'll have the direction set to 9. Enable is 10. And then the motor counter, which we'll get into this later, we're going to use this as a delayed start. We'll set that to 1000. And that's not the same as the lock or the speed or anything. That's a separate variable. And I'm using this type of controller right here, one of these black boxes that you can buy on Amazon all over the place. I'll put an affiliate link to that in the video also. But I have 3 pins, which were enabled direction, and pulse, or clock. I call it clock, but it's just a pulse. When you go up and down, it triggers the stepper to take a step. And then in the main loop, the first thing I do is there data on the serial 2 port, which is the Nextion port. And if it is, I run this input function, which is over on the input tab. I look at the DFD. I collect 1 character at a time. If it's greater than 3, if I've gathered 3 characters, I check to see if it's C:C. If it's not C:C, I reset the DFD back to empty. And then I start collecting the characters again. This allows me to get back in sync. This really isn't the best way to do it because I am missing 2 characters. If you really wanted to do it right, you would look at the first character and make sure that it's a C. And if it's a C, you'd go on. And then you'd look at 2 characters, make sure it's C:, and then finally the 3rd character. This would allow it to reset anytime there's any sort of bad, or there's a bad command or something sit between the Arduino and the Nextion. But for now, this has been working fine. Then I look at my substring, and I make sure that the last character is a question mark. So you can't use that as your ending delimiter if you're going to have question marks in either your commands or your values. But as long as you're not, and I haven't run into that yet, so I just look for that question mark. I know the command is over. And once I establish that, I start to break it up. And I know the first 3 characters are C:, so I skip those. And then the next 3 characters are the command. And you could change this here, and you could make it 4 characters, or whatever it is you want to make it. But 3's worked pretty good. And then the rest of the string, other than the question mark, so I subtract 1 from the length of the string, is the value. And then sometimes I comment this out, this serial print line command and value, and sometimes I don't. But in this case, I'm going to leave it in there. And if the command is SPD, which means it's the value coming from the slider, then I'm going to turn that into an integer. Well, the value will turn into an integer because I'm assuming it's going to be between 300 and 3300. And then I turn that into my delay length. And then that affects how fast the delay happens, or how fast I clock that motor. Once I get the command run, which tells you I'm going to go forward or reverse, first thing I want to do is I want to enable the motor. So I'll set that to low. And then I'm going to wait 250 milliseconds. And I'm going to set the motor counter equal to 1000. And we'll get into that because that'll happen over on the other page. But if the value is forward, then we're going to set the motor direction low. And if it's reverse, then we're going to set it to high. Now, I don't know how this will operate on yours, and you may switch low and high here because you might say, well, it's going backwards. Well, if it's going backwards when you think it's going forward, then just change this to high and this to low, and you should be fine. Now, if we get the command motor, which is being sent by the timer, so it's not being sent by the button press. It's once we release the button, then the timer kicks in and it sends motor OF. But we really don't care about the value in this. We just know every time we get a motor command, that means stop. So we're going to send a few commands up to the Nextion. We're going to start with this timer. We're going to disable it. So that way it doesn't send that anymore. And then we're going to set the motor lock equal to 0, which will allow us to press the forward button again. And depending upon the state of the radio buttons, we have to set those back to green because we don't want them to stop in a red state, because once we disable that timer, it's going to stop flashing the colors. So we're going to set that to green. And then we're going to take that motor enable pin and we're going to set it to high, so we'll disable the motor. So even if it was sending steps now, because something messed up, we're going to disable the motor. And then once again, I throw this delay in there every once in a while when I change the state of the motor, because I want to make sure that it's fully stopped or fully started, and we just pause the Arduino. And then after we've checked for all these commands, we'll reset the DFD back to empty. Then we're going to go back over to the delay. And this is where we'll get into where we have this motor counter equal to 1000. So I've changed the delay from the last of milliseconds to microseconds. And we have a range of 300 to 3300. But since we're going to do that, we need to worry a little bit more about the rollover. So I've added some notes up here. And so we've got this first step here. So if micros, or if the microsecond counter, which is an internal counter in the Nextion, or in the Arduino, if it's less than the delay length, which we're going to start at 1800, and the micros is going to be 0. So originally it is going to be set next to the delay length. But as the micros counts up, it's going to hit this huge number here. And once it hits that number, it's going to go back to 0. So that's called the rollover. We want to make sure that our async delay also goes back to 0. So when the micros is less than the delay length, in other words, it's 0 to 1800, we're going to keep setting this async delay equal to the delay length, because the async delay is going to count up with those micros, and eventually it's going to hit this large number too. So this should be a little trigger. Now I've gone over lots of different ways to check for this rollover, and lately in the videos I just don't even mention it, because when you're talking microseconds and you can get that high, we'll never hit it in the video. But I was a little bit worried in this since we are dealing with microseconds. So right now this is the way I'm doing it, and hopefully it works. And then down here is where we're going to do the main loop. So if microseconds is greater than the async delay, we're going to do something. And so this is what you're more familiar with my videos. The first thing we'll do is we'll increase the async delay. But notice we're going to add not only the delay length, but we're going to do this motor counter times 2. So, and we have it set to 1,000. So it's actually going to add 2,000 to whatever the delay length is. But down here in the loop, if the motor counter is greater than 0, we're going to subtract from the motor counter. So every time we run through this loop, it's going to go down by 1. So the first 1,000 times through the loop, the delay is going to be long. And eventually it'll just become the delay length as the motor counter keeps decrementing. What this is going to do is this is going to cause the motor to spin slower at first and slowly ramp up to speed. And since the motor enable pin is active low, we're going to check for the not condition with this. So when the enable pin is low, we're going to flip the bit. So we're going to step or send a pulse to that pulse bit and make the stepper motor take a step. And we set that enable bit only when we press the button and it's on back in the input. So if we go back over here, only in the run will this be low, because once it gets the off signal, it'll be high. So whenever it's low, we're going to do this counter thing, which is going to add a little bit of time, and we're going to toggle that output, that motor clock pin, or the pulse pin, however you want to determine it. So when you press the button, it'll send that, it'll turn it on, it'll tell this thing to start counting, and it'll send pulses based upon the speed that you have set on that slider. But we're relying on feedback from the Arduino to go back to the display to tell the display that it's okay to press a button again. I'm going to switch to a camera now and we'll show it to you live. So I have this configuration set up. I have my stepper motor. You can see the TB6600. The Nextion display isn't coming through the best, but I'll zoom in a little bit. And then over here I've got my Nano. And then I see that little yellow thing in the middle. I'll highlight it. But that's a little switch. And using that switch, I can go between programming the Nextion and having it connected to the inputs on the Arduino. And that makes it nice when I'm going between things. Just flip the switch, submit a new program to the Nextion, flip the switch back, and I'm connected to the Arduino. I'm going to have to kind of hold the camera, so if it's a little bit jittery, I apologize for that. But hopefully you can get the idea. I've got the COM port open on the Arduino so we can see the commands going back and forth. And you'll see me, I'm going to hit the reverse button. And you can see that the steps that it's going. Remember we have that little ramp up. So I'm going to set the slider all the way to its fastest. This time I'll hit the forward button. And you can see that it starts slow, and then it goes fast. And if I hit the reverse, it does the same. When I release, there's a little bit of a delay. But if you remember, the timer is the one that is shutting it off, and it's running at a 400 millisecond pace. So that means it can take up to half a second for it to show the disconnect. I'm going to also do an experiment. I'm going to hold it, and if I drop the camera, I'll cut back in. But what I'm going to do is I'm going to hit the forward button, and then I'm going to go down on this little switch here. I'm going to change it so that it's switched to the Arduino or to the programming mode, so it's not connected to the Arduino, and then it will stop sending commands. And you can see I'm getting the flashing now, because what's happening is the Nextion is trying to tell the Arduino it's time to stop, it's time to stop, it's time to stop. And that's why we want to send it over and over again. If we only sent the one command when we release the button, then we wouldn't know that the motor hasn't stopped. But in this way, the Nextion knows that the motor is still spinning because the Arduino isn't telling the Nextion that it's not spinning. So now if I flip the switch, it should stop because it got the command. Now the only thing is this time would be nice when I let go of the button to have it stop a little bit quicker. And we can do that by just adjusting the timing in the display. I mean the timing in the display. If I take this timer, and adjust this to its lowest, which is 50 milliseconds, I've got to flip that switch, and I should be able to upload it. Now also the motor should be more responsive. You can see it shuts off right away now. I kind of like that ramp up. Of course, on the slowest speed, you might not even be able to tell. Because you're going from 5 seconds to 3 seconds, or 5 milliseconds to 3 milliseconds. So you can't really see the difference. But you can see we get all of what we would expect here. And here was our speed change. I'm going to set it back all the way down. And I'm going to do the forward button again. And disconnect it. And you can see we're not getting that motor off until I turn it back on. And then we get it. The other thing is I think we could hold the button down. I can change the speed while the button's being held down. So that's kind of interesting too. So this was an update to an other video that I had that people had complained that it moved kind of slow. And I think the real problem with that was using the microseconds instead of the milliseconds. That change made it go a lot faster. And a lot of people didn't even know that the microseconds existed. And you can do the same thing in a delay. There's the delay, if you just put delay and you put 500 in the parentheses, it will be 500 milliseconds. But there's also a microsecond delay that you can use. But the biggest difference that I know is that I've added this opening this delimiter, this C:(C), and then this question mark is an ending delimiter, which really makes it clear when you're sending commands between the two devices. And in the old way, I didn't have that. So people would send me the code to review, and I'd have to kind of go back more steps than I wanted to. Now with this video, I should be able to just say, hey, if you're having a problem with 151, which is the video number, just check this video out, 201, and hopefully it'll help you a little bit more along. And then if you have any questions, feel free to go over to the cheapcontrols.com website and submit something through the help tab or the help page. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.